All right, so let's finish this thing up. Problems 9 through 11. Here we go. Okay, so first problem, fairly straightforward little question where we have a common base that's pretty easily recognizable. We're playing around with the number 4 in this. 64 is 4 to the third, and 16 is 4 to the second. So now that we have matching bases, we just simply want to match up those exponents. So 3x plus 3 would be equal to 10x minus 2. Doing a little bit of distributive property here, let's just move things around, subtract 3x from both sides, add 2 to both sides, which should give me 5, and x would be 5/7. Now keep in mind, as I spoke to you guys in class, it's really smart to take something like 5/7 and store that as a. I like doing that because now if I take 64 and I raise it to the a plus 1 power, let's see what happens. I get, some kind of ugly looking decimal. But then if I took 16 and I raised it to the 5a minus 1 power, hopefully I would get exactly that same decimal. And that kind of confirms that I did okay. The second part, didn't want to do very many of these because we had just done them in class. We don't have a common base. So what we're going to do is we're going to take the log of both sides. And the reason we do that is that allows the exponent to pop in front. Now, part of the reason doing that is so we don't deal with a variable that is in that exponent. And what I had you guys do in class is get rid of those darn parentheses so we are in a position where we can move things around. Now, again, my goal is to get x by itself, so I definitely want to get all of the x's on the same side together. So I'm going to add 2x natural logs of 11 to both sides. And I know this looks just like kind of a mess, but since I have x in common on that side, that allows me to factor that x out of both of those. And so since right now x is being multiplied by all of this stuff, all I have to do to finish it is divide by that block of information. So I'm going to divide both sides by all of this right here. And so as such, if I divided both sides by it, I would have 5 natural logs of 11 on top, and the bottom would be 2 ln's of 11 plus 3 ln's of 7. Now, we can check this answer, but it is substantially harder to do on our calculator. But I'll show you what I would do. Parentheses, 5 ln of 11, close, close. I have to basically start off the numerator and close the numerator. Let's divide that by 2 ln 11. Now I notice there's an opening to the parentheses here, which opens the denominator. That opens the natural log and closes that natural log, plus 3 ln of 7. I have to close that natural log and then close the denominator. This value is what I just got as my answer. So if I stored that as a again, I always use a. I could check my answer because the question was 11 raised to the 5 minus 2x power, which again we stored as a. So that's my first side, and then the other side is 7 raised to the 3a power, and hopefully we're going to get exactly the same number, and that confirms that we did well. Okay, so that ends up number 9. I know that those answers were good. Number 10, we're going to play a little bit with our change of log base formula. This problem really should have been phrased in base 3 because, of course, 81 and 27 are very closely related to that. So our change of base formula says make your original question up here, your original base, and then pick your new. And then 3 to what power is 81? Well, 3 to the 4th power is 81. And again, if you don't have those memorized, you could certainly play with this and see if you could figure out what actually works. Like some of you might have thought maybe it's 3 to the 5th. Well, but that's a little too high. So 3 to the 4th looks better. And similarly, 3 to what power is 27? That number would be 3, and so we're good. Now, keep in mind, checking our answer, according to our definition, if 4/3 is my answer, I should be able to take 27, the base, and raise it to the 4/3 power, and that should, in fact, give me 81. So that does tell me that I did that problem Correct. So I'm going to go a little quicker through this one. This is a cube root, which is a 1/3 power. So I could bring that in front. The next thing that I notice is that I really don't appreciate the fact that this is log base 16. I would much prefer if this was log base 2. So we'll put our original question on top, our original base in the bottom. And how many 2's does it take to make up the number 32? Sorry, something just came in front of my screen here. Hopefully that didn't show up in the video here. So we're rendering the other part of it, but 2 to the 5th power is 32 and 2 to the 4th power is 16. So it looks like 5/12 would be our answer. I'm going to go ahead and hit stop share and reshare just to make sure that our video is not messed up. Okay, so making sure that we're actually getting what it is that I want you to see. And then my very last question on the review for me is that we want to put this all together, and we have good bases here, here, and here, but we don't really like this base right here. So I'm just going to go ahead and mess around with this thing right here, and I'm going to write the log base 4 of k over the log base 4 of 16, because I would really like this to be the same base as these other guys, but I know that 4 to the 2 power is 16. And of course, 2 times 2 is 4. And the rest of this, I really haven't done anything to yet. I've just sort of been waiting to figure out what happened. I had the log base 4 of x here. I had the log base 4 of y here. I had 2 log base 4s. I ran out of room of y up here. But then, of course, if we put those all together, remember all of the tops are the positives, so x is going to go on top. Y is going to go on top. This y squared is going to go to the bottom. And, of course, this is also a negative off of this part. And so it would be a 4th root of k down here. And this is not a bad answer. However, if you're paying attention, you would notice that we have y's on top and bottom. So we could simplify that just a little bit and notice that we still have an x on top. We have our 4th root of k on the bottom, but of course a y over y squared would leave a y on the bottom. And if we had been watching for it, we would have seen right up here that if you have 1 of something, and then you take 2 of those same things away, you could have combined those like terms to call this negative log base 4 of y, because I have 1 of something minus 2 of those same things. So we could have done that and been able to skip straight to this last step without needing to simplify in the logarithm, but there was nothing wrong with doing that. But that's the end of our review. Please let me know if you have questions back in class. I'll see you there. Bye-bye.